Oh, hello. Welcome to OneTake. So, I woke up this morning with a realization. All this, everything we've been talking about, movies, TV shows, sometimes even comics, it's all frivolous and ultimately a waste of time. And time is important because, as you know, in this life, you only get one take. But you know what's not a waste of time? Spreadsheets. Spreadsheets bring structure to the unstructured. They bring logic to the illogical, and they bring order to chaos. So that's going to be the focus of OneTake from here on out. We'll start off with some of my favorite Excel techniques. You can use the chapter markers to skip ahead, or just sit back and enjoy the spreadsheets. Today, we'll be looking at how to compare two or more lists in Excel. We'll be comparing the lists to look for commonalities or matches across them, and we'll be looking for any differences. In this example, let's pretend that we work for a company, and each week HR sends an updated employee roster. HR would like us to run an analysis comparing each week's roster to the last, to look for employees that have been added or employees that have been removed. In this example, just to make it a little bit more complicated, let's pretend we're a little bit behind, so we need to compare the last 3 weeks to one another. As always, if you'd like to follow along with this example, hit the link in the description to download a copy of the example file we'll be walking through here. In this file, we have 3 tabs. Each one represents an employee roster from a particular week. For the latest, we have a roster from May 15th, another from May 8th, and another from May 1st. When faced with this situation, a lot of people will be tempted to use a VLOOKUP or a match formula. For example, if we go to the most current roster, we can add a column here that says match and do a quick match formula. We'll be looking for that employee ID on the previous week's roster. And we can copy that all the way down and see where we have a match, where we see a number, that means the employee was present on the previous week. Where we get an NA, that would tell us the employee is new. Now, this method does work. However, it gets more complicated once you get to comparing more than 2 lists. And even with 2 lists, it can get confusing because we'll have to do the match formula on the current roster to check who has been added. Then we'll have to go back to the previous roster, do a match formula there to see who was removed. And you can very easily get confused trying to remember, wait a minute, does this NA mean the employee was added or does it mean they were removed? It basically turns this whole thing into a brain teaser, especially when you're dealing with more than just 2 lists like we're dealing with here. So I'll show you my preferred method that I think is a little bit more efficient and a lot less confusing. The first step of this process is taking each of your lists and combining them into one big data set. However, when we combine them, we want to make sure that if we look at a particular record, a particular line item on that list, we know which list it came from. So let's go into each of these rosters and add a new column that labels which version of the list each record is coming from. In this example, when we say which version of the list, we're essentially talking about which roster. So on the May 1st roster, I'm going to add a version column and just write May 1st. Copy that all the way down. I'm going to repeat that process for each of these other tabs. And usually when I add a column to raw data, I like to highlight that column. So if we go back to this in the future, we'll know that column B onward, that was the original raw data that was provided to us, and the version column is something new that we added. So now on each of the roster tabs, we have a new column which labels each record indicating which version of the roster that record came from. And you can customize this column so it makes sense for your situation. For example, if you are dealing with just 2 lists, you could label one list as old and one list as new. So when you combine them, you can see which records came from the old list and which records came from the new list. Now that we've got our new columns added, let's go ahead and combine these lists onto one tab. I'm going to create a new tab called Combined, and I'm going to copy the roster from May 1st onto this new tab, and I'm going to make sure to paste values. In this case, we don't have any formulas, but it is possible that the data you're dealing with will have formulas, and you won't want to carry those over because you could break them or they might not work when they're pasted on this new tab. So I just pasted values and then I pasted formats just because I want this to look nice. And when you copy the second one, you don't need to copy that header again because we already have it from the first roster. And now let's copy the third roster. Now we have all three rosters combined onto one big data set. If I scroll down, you'll see we have the May 1st roster, the May 8th roster, and finally the May 15th roster. That means that some employees will be on this list multiple times if they were present across multiple iterations of the roster. The next thing we're going to do is create a pivot table off of this data set. So I'm going to select all of the data in this new combined data set and then insert a pivot table. So we'll do that on a new worksheet. And once we've got this new pivot table set up, here's how we're going to set up the rows and columns. We want employee ID, first name, and last name to be your rows. Then we'll want version to be the column. And I'm also going to take version and put it in values. Now, because version is just a date, if you remember, the version column is where we put the roster date, rather than a sum in our pivot, we're going to get a count. And that's exactly what we want. Now we just need to get this table formatted in a way that it's useful for us. So hit the Design tab on the ribbon, then turn off subtotals, turn off grand totals, and under Report Layout, click Show in Tabular Form. So you can probably already see where we're going with this. The table has been set up in such a way that every single employee is listed, and going from left to right, we get an indication of which rosters that employee was present for. So for example, we can see here Rebecca Allen was on the May 1st roster, she was on the May 8th roster, but she's not on the May 15th roster. The reason this works is because when we combined all of the rosters onto one tab, as I mentioned earlier, an employee will show up multiple times in that combined data set if they were present on multiple rosters. However, for each of the records where that employee shows up, that record will look unique because it's labeled with a date, the date indicating which roster that record came from. Let's look at Rebecca Allen as an example. If we go to the Combined tab and I throw a filter on this list, then I filter to Rebecca Allen, we can see that Rebecca is on here twice. One for her May 1st record and one for her May 8th record. On the pivot table, we're using the count function to summarize. An employee should only be on a roster once, which means when we're looking at employee counts, we should see either a 1 if they were present on that roster or a blank if they weren't present. So very easily we can see Rebecca was here for May 1st, May 8th, and is not here for May 15th. So we're almost there, but let's do a little bit of cleanup so we can make a good, clean report out from this analysis. First, right-click on the pivot table, then hit Pivot Table Options, and next to For Empty Cells Show, instead of showing a blank, let's tell it to show us a 0. Now, we're going to copy the data from this pivot table and paste it somewhere else so we have the data in a raw format in a way that's easier for us to work with and do whatever we want with it. You might have this blank column here. You can just ignore that. So I'm going to copy all the way down. I also have a blank row over here. I'm going to ignore that and then copy this and paste it to a new tab. Right now, it works, right? We can scroll down and see employees that have been removed. We can see employees that have been added. Honey Nelson, for example, was not here for a couple of weeks, and then Honey showed up on May 15th. But we have to scroll all the way through to find these employees that had some kind of a change in their status. Let's sort this data so we can get all of the employees that have had some sort of a change, get all those employees right next to each other so we can quickly see the important results of this analysis. So I'm going to select all the data and I'm going to add a sort. And I'm going to do that by either using the shortcut key, Alt-DS, or by clicking on the Data tab and hitting Sort. So what we want to do here is, for the first column, select our rightmost version column. Then we want to select, moving from right to left, the next one, and finally the oldest column. And for each of these, we want to sort smallest to largest. Then hit OK. What that's done is it's sorted our list so that any employees that have experienced some sort of a change have been clustered at the top of the spreadsheet. So right off the bat, we can see we had 4 employees that were present May 1st and May 8th, and then were removed on May 15th. We can see we have 10 employees that were just added on May 15th. You can see from the zeros, they weren't here on the May 1st roster or the May 8th roster. And then finally, we can see a couple of employees that were added May 8th. They weren't here on the May 1st roster, but they were there on the May 8th roster. So that about covers it. I'm a big fan of this approach because you get a good, clean report out at the end of the process. You don't have to mess around with lookups or match formulas, so you don't risk getting confused over what an NA actually means. And this works for any number of lists. In this example, we looked at comparing 3 lists, but it would work just fine with 5 or 6 lists. You can also imagine how this would be useful for more than just telling if somebody was added or removed from a list. You could also use this for more complex scenarios. For example, imagine if you had a product listing and each product had a specific price. Let's say that you get a product sheet and then you get a new version of that product sheet, and at the bottom you see that your total cost has changed, but you're not sure why it changed. Is it because you added more products to the list? Is it because a couple of products had their price changed? You could use this exact same method to compare the old product list to the new one, but instead of using the count function on your pivot table, you could use the sum function. And that would tell you if the total cost of a product has changed from one version to the next. Anyway, if you're new to the world of Excel or the world of finance, you will be amazed at how often you need to compare lists to each other. So make sure to keep this method in your back pocket, and you will become a great asset for people in your office. You'll be the guy or gal that everybody comes to when they need to compare lists. Today, let's look at how to create dynamic lists which depend on one another. For example, let's say we have a company with 3 divisions: aerospace, medical, and food. Within each division, the company has several segments. In aerospace, they have the satellite segment, human spaceflight, rideshare, etc. We'd like to create 2 drop-downs. One drop-down where the user can select a division, so it'll be those 3 divisions we saw before. Once the user has selected a division, we would like the second drop-down, the segments drop-down, to change depending on which division has been selected. So rather than listing out every segment in the company, when I click this drop-down, I would like to only see the segments within the selected division. So we've selected the medical division. When I click this drop-down, I should see only the segments within medical. And you can see that's how we've set this spreadsheet up. If I go back and select aerospace rather than medical, you'll see that when I next click on the segment drop-down menu, I'm only seeing the segments within the aerospace division. So in a moment, I'll go to a version of this spreadsheet where these drop-downs aren't set up, and we'll go step by step through how to get them working this way. And as always, if you'd like to follow along with the example, click the link in the description to download a copy of this example file. And just to provide some context on where you might use this in the real world, we've set up a small budgeting tool here, the sort of thing that you might use in the finance world. In this example, we have an input sheet where a user can list out various purchases they plan to make in 2021. For example, we might say that in the aerospace division for the satellite segment, in April, we plan to spend some money, let's say $1 million, on raw materials. This feeds into a summary tab that shows us how much we plan to spend by segment, by division next year. So you can see our $1 million to support satellites listed there under April. The dynamic dropdowns in the division and segment columns help to ensure that users are only inputting spend to actual segments and actual divisions. By limiting the segment column based off the division selection, it helps guide those choices and makes things a little bit easier for the user. So you can play around with the logic that summarizes everything on the summary tab, but the focus of this tutorial will be on setting up those dropdowns. First, let's set up the division dropdown. To do that, we need to have a list somewhere that lists out the 3 divisions. Usually, if I'm going to have multiple lists used in a workbook, I'll create a tab simply called Lists. If you navigate to the Lists tab, you'll see we already have one list, and that's the list of months. This is used for the timing dropdown, where a user can indicate which month the spend is going to take place within. If we go back to the Lists tab, we are going to first create a divisions list. So over here in cell E6, just type divisions. I'll bold that for now, and then list out the 3 divisions. We already have them written out on the summary tab, so I'll go ahead and copy and paste them from there. I'll click on the summary tab, click on aerospace, and then while holding the control key, I'll click medical, and I'll continue to hold the control key, then click food. Holding the control key means that as I click on different cells, they'll be added to my current selection. I've now selected those 3 divisions. I'll press Control C to copy them, or you can right click and click copy. And then I'll navigate back to the lists tab and just paste beneath the divisions column. And I'm going to press Control B just to unbold them, just to keep consistent formatting, where the header is bold and everything listed under the header is not bold. Now that we have our list, let's go back to the Input tab and put this into our dropdown. First, select all the cells where you'd like to create a dropdown menu. In this case, we want to select all the cells under the division column on the Input tab. I'll do that by selecting cell C6, and then I'll scroll down to the bottom of the spreadsheet, and while holding down the Shift key, I'll click on cell C30. When you hold down Shift and select 2 cells, Excel will select the first cell, the last cell, and all the cells in between. Now with all of those cells selected, I'll navigate to the Data tab on the ribbon, and then click Data Validation, this button right here. By the way, you can also get to data validation using a keyboard shortcut, Alt-A-V-V. Right now, under Allow, by default, Excel will have any value, which means that the user can enter any value they'd like into these cells. We would like to have a dropdown or a list, so click the dropdown here and select List. Under Source, we need to tell Excel which options can the user select from. Click on the text box underneath Source, and then click this button here to the right. Navigate to the Lists tab and select the 3 divisions. Then you can click this button here to save your selection. Then press OK. Now, if you click on any cell in the division column, you'll see this arrow pop up, which you can click to see the dropdown, and you'll see that all 3 divisions are available as an option. By the way, data validations can also be done with a named range. I'll show you what I mean by that in a second, because we'll have to use named ranges when we get to the segment column. Navigate back to the Lists tab. We want to create a named range called Divisions, which refers to our 3 divisions. The easiest way to create a named range is to select the range you'd like to name, and then in the upper left corner, simply type in the name. In this case, we want to call this range divisions. If you're unfamiliar with named ranges, all it means is you've created a shorthand to refer to a range of cells. Previously, if we wanted to refer to this range of cells, it would look like this. Lists E7 through E9. We are essentially giving Excel directions to find those cells. However, now that we've named the range, rather than equals lists E7 through E9, in our data validation window, under source, we can simply type equals divisions and then press enter or OK. And you can see the drop-down works just fine. So let's do that again, except this time, rather than changing the data validation for just cell C6, let's change it for all the cells under the division column. So as before, I'm going to click on cell C6, then scroll down to the bottom of the spreadsheet, and then while holding the Shift key, I'll click on cell C30. Then I'll go back to data validation, either by going to the ribbon under the Data tab and selecting Data Validation, or by pressing Alt-A-V-V. Now, because cell C6 is currently using a named range and the other cells are still using a normal cell reference, Excel's giving us a warning that we are changing the data validation properties of multiple cells which contain different properties. To move on, you can simply click OK, because what we're saying is we don't care that we have different data validation properties in these different cells. We want to set up a data validation that will be consistent across all of them. So by pressing OK, you erase the current settings, and whatever you set here will apply to every cell you've selected. So as a reminder, under Allow, we want to select List, and for Source, rather than navigating to the Lists tab like we did before, we'll simply type equals divisions. And divisions is a named range, so when Excel sees this, it'll know which cells you're talking about, and it'll pull in your list of 3 divisions. And we can see it worked. By selecting any one of these cells and hitting the drop down, we see those 3 options. Now let's go to the segment column. We want to set it up so that when you've selected a division, you can then click on the cell next to it for segment and see a drop down of all the segments within that division. The first step is we need to create a new list for each division. We want to have a list of each of the aerospace segments, a list of each of the medical segments, and a list of each of the food segments. So let's go back to the Lists tab and create those 3 lists. First, let's set up the aerospace list. Here we have the list of divisions, and we've bolded the word divisions at the top of the list as the header, so we know what this list is for. We'll do the same thing over here. I'm going to paste the word aerospace, and I'm going to bold that, and then we'll list the aerospace segments beneath the word aerospace. Similar to before, we have that list already on the Summary tab, so I'll go ahead and copy and paste that over. I'll navigate to the Summary tab, I'll select all of the segments for aerospace, I'll copy them, return to the Lists tab, and then I'll paste them here. However, I'm going to use paste values because we have some different formatting on the Summary tab. We want to keep the Lists tab really clean without any special formatting, so I'm going to right-click and right here, click Paste Values. And then I'll double-click between columns F and G just to get the proper column width. Let's repeat those steps for medical and food. I'll copy medical over here, bold it, back to the Summary tab, select the 4 segments for medical, I'll paste values. This time I'll use the keyboard shortcut, Alt-E-S-V, enter. And then again I'll fix the width of the columns, copy food over, bold it, back to the Summary tab, copy all of the food segments back to lists, paste values, and again, fix that column width. And before we move on, I'll do a little bit of formatting cleanup just to make this an easier spreadsheet to work with. First, I'll insert a column between columns E and F. And I want to make this just a small column to create some separation between the divisions and the segments. So I'll copy column D and paste it into column F. Similar to the months column, I'll highlight the divisions header. And I'll just make that kind of a darker gray. And then similarly, I'll highlight the headers for the segments. Again, I'll use that kind of darker gray. And I'll write segments over here just to make it clear that this section is for listing all of the segments. And to further the formatting, just to make it a little bit easier on the eyes, I'll select the headers and make them a lighter shade of gray, just to create some separation between the main header, we're talking about the segment section, to sort of the subheaders that lead each of the individual lists of segments. Now let's name each of these ranges. So let's select all of the segments beneath aerospace and navigate over to the name box here and type in aerospace. Then press enter. We've just created a named range called aerospace, which contains all of the segments within aerospace. Repeat that process for medical. So select all of the segments within medical, click on the name box, and type medical. Finally, repeat that process for food. Select all of the food segments, click on the name box, and type food. Now we've named each of our ranges. By the way, if you want to see your named ranges, you can click on the Formulas tab in the ribbon and then click on Name Manager. And you can see each of our named ranges. You can see what range they refer to and actually what values are currently included within that range. Using named ranges for data validation is useful for a couple of reasons. One, if you ever need to change the range that's included in a data validation, named ranges makes that easier. For example, let's say we have to add a new division. If we want to make sure that this newly added division is included in the drop-down menu, we need to update the list of cells included in the data validation. The normal way to do that would be to go back to the Input tab, select all of our cells that include the data validation, go back into data validation, and update this source to include that added division. Hit cancel. The problem with that method is that it adds an extra step to the process. Rather than simply updating the list of cells included in the data validation, I first need to know all of the cells which use that data validation, and I need to select all of them. So I need to select, as I showed before, C6 through C30. In this spreadsheet, that's not such a big deal, but you could be working with a workbook that has a lot more cells you would need to select. Using a named range makes it very easy. All you have to do is go into your name manager like we showed before, Formulas, Name Manager, and then you simply update the division's name here by selecting divisions and then clicking this button right here. And now you can change that list. Once you update the list here, all of the cells using the data validation referring to the division's name, all of those cells will automatically be updated. So rather than having to select all of those cells, all I need to do is update the named range, and you can rest assured that the change will carry through to all those cells. Now I'm going to change this named range back to those original 3 divisions because that was just a quick example. And I'll get rid of that new division there. So let's go back to the Input tab. In the segment column, essentially what we want to do, if I go into data validation again, and then I want to set allow to list, if the user has selected medical as the division, I want the source to be equals medical. because we have a named range called medical, which refers to all the segments within medical. Here I've typed equals medical as an example. I'll press OK, and you'll see that under segment, I can only select from the medical segments. However, if I change this division to aerospace, for example, you'll see that my segments are still just the medical segments. So let me go back into data validation. How do we set up the source so that it's equals medical when it needs to be, but if the user selects aerospace or food as the division, our source becomes the aerospace list or the food list? To accomplish that, we'll use a function called indirect. I'm going to click cancel here and show you how the indirect function works. Navigate over to the indirect example tab. The indirect function takes a text string and treats it like a cell reference. For example, if we wanted to know what was contained in cell F13, you could use a direct cell reference. So for example, in cell D6, I'm going to enter equals F13. This is a basic cell reference, so when I press enter, Excel will show me the contents of cell F13. However, what if we wanted to set up some functionality where a user could enter any cell here in cell D4 and see what's contained within that cell? So I'd like to be able to enter I10, and then I would like to see the contents of cell I10 right here. So how do I do that? Well, right now in cell D4, we have a text string that simply says I10. If we were to treat that text string like a cell reference, then Excel would know to look in cell I10 and tell us what's contained within it. Well, that's exactly what the indirect function does. So let's try it out. In cell D6, type equals indirect, open parentheses, and then select cell D4, and then close parentheses. So what this formula is going to do is it'll check cell D4 for a text string, and it'll find in cell D4 we have the text string I10. The indirect function will treat that text string like a cell reference. If you were to take I10 and treat that like a cell reference, then Excel would simply look in cell I10 and return the contents of that cell to us. So press enter, and you can see it did exactly that. And if I type in F13, it'll pull in the contents of cell F13. In this example, the indirect function is not very useful, but it becomes incredibly powerful when you realize that a named range is nothing but a cell reference. So let's put that to use. Navigate back to the Input tab. Then select all of the segment cells. So click on cell D6, then scroll down to the bottom of the spreadsheet, and while holding the Shift key, select cell D30. Then, as we did for the division column, navigate to the data validation function. So click on data, then data validation. We get this error that we saw before. Right now, cell D6 contains the data validation that we did as an example, but cells D7 and onward do not include any data validation. So again, Excel's just asking, do we want to make all of these cells consistent in terms of the data validation that they use? So you can click yes. Now, the way this spreadsheet is going to work is the user will first select a division in column C. In this case, in this example, they've selected aerospace in cell C6. So what are the contents of cell C6? We have a text string which says aerospace. What do we want column D to have, or cell D6 in this example? We want cell D6 to have a drop-down menu using the aerospace list. Well, remember, we have a list called aerospace, and named ranges are essentially cell references. So if we use the indirect function, we can take the aerospace text string and tell Excel to treat it like a cell reference. which in this case is a named range that contains the list we want Excel to use for this drop-down menu. So clear what we currently have in the source field, and then type equals indirect C6, and then close parentheses. So what this tells Excel to do is take a look at cell C6 and look for a text string. You will find the text string aerospace. Now, use the indirect function to treat that text string as a cell reference. When it does that, it'll find, hey, aerospace is a named range, and that named range contains a list. Let's use that list as our drop-down menu. So I'll go ahead and press OK, and now you can see when I click on the drop-down menu, I see all of the aerospace segments. And if I change that to the food division, for example, all of the segments are now the food segments. And that's because Excel is taking the text string from cell C6, treating it like a cell reference, so in this case it's finding that named range, and pulling in everything from that named range into this segment's dropdown. You'll see this works for all the other cells as well. If I go to cell C7 and I select medical, then in the drop-down menu in cell D7, I can see the medical segments. I'll show you the reason that works. If you once again select all of the cells under the segment header, so click on cell D6, scroll down, hold the Shift key and select cell D30, then you can let go of Shift. I'll navigate back into data validation. When you select a collection of cells and enter data validation, whatever you enter in this source field will be treated as the source for the first cell in your selection. So this says that for cell D6, I want you to look at the text string in cell C6. However, this is only the source for the first cell in this selection. For all of the other cells in this selection, Excel will act as though we've taken this source and copied and pasted it all the way down. If you're familiar with cell references, you'll know that if I have C6 in my first cell, as I copy and paste it down, that 6 will update as we move down. So in my first cell, I'm looking at cell C6. But if I paste that into the cell below, I'll be looking at cell C7. And you can prove that to yourself by hitting cancel. And then rather than selecting all of the cells, just select one of them. So for example, click on cell D9. Then navigate back to data validation, and you can see that as the source, it's using cell C9 rather than cell C6. Now I'll hit cancel to get back to the input tab. And now you have dynamic dropdowns that depend on one another. You can test it out and see that it should work across all the cells on this spreadsheet. For example, I can come down to cell C14, select aerospace, and then see in cell D14 that I have all of the aerospace segments available. You can even get more complicated, and let's say within each segment you had products. You could insert a third column that has a drop-down list which depends on the segments column, and on and on. And if you ever had to add additional divisions or additional segments, you can do that by listing those divisions or segments on the Lists tab and going back into Formula's Name Manager to update these ranges to include any added divisions or segments. Today, let's look at how to identify the last cell in a column or a row that contains value, and we'll also look at how to identify the first cell in a column or row with a value. If you'd like to follow along with this example, as always, click the link in the description to download a copy of the example file. When you open up that file, you'll see this. We have a couple of examples set up. First, we have this blue highlighted row where the first cell containing a value is in column Q, and it just contains the phrase first value. Then we have a bunch of random text, and our final cell in the row contains the term last value. And we have a similar example set up in column H. So we can try looking for values in a column and in a row. So the output of this tutorial will be this. We're going to return the last or first cell in a column or row in basically 3 different ways. One, we'll retrieve the column or row number. For example, we'll find that the last cell in column H is in the 36th row. Then we'll look at how to return the actual value that's stored in that cell. In this case, it's either first value or last value. And finally, if you ever need to, we'll look at how to return the cell address. So we can see, for example, that the last cell in this column is located in cell H36. So let's go through how to put these formulas together. Now we're going to have to work with some array math here, and I'll explain what that means in a second. But that means it's going to be slightly easier to do in the latest version of Excel, Excel 365. But with a couple of small tweaks, we can also make it work in previous versions of Excel. So just follow along, and then I'll tell you the one small tweak you can make if you're on a previous version of Excel. So go ahead and type equals, open parentheses, then pick column H, and then type in the symbol for not equal to. That symbol is this left arrow, right arrow, and you can find those 2 keys between your M key and your question mark key, and then put in double quotes and close parentheses. Now, when you are working with a range of cells like this, in this case, the entirety of column H, and you apply some sort of math to it, like we're doing here, that is array math. Because a range of cells, or really anything that contains more than one value, is essentially an array as opposed to a single value or a single cell. When you apply some kind of mathematical operation, in this case, checking whether or not something is equal to a blank, or specifically, we're checking if something is not equal to a blank. When you take that sort of mathematical operation and apply it to an array, essentially what Excel does is apply that mathematical operation to every value in that array. So in this case, we're telling Excel, go through every cell in column H and check if it's not equal to a blank. Then it's going to return either a true or a false, which Excel treats as a 1 or a 0, 1 for true, 0 for false, meaning the result of this operation here is you will get a bunch of zeros and ones. It'll be a bunch of zeros for blanks and ones for values. So if you wanted to picture it visually, it would look like this. You have zeros wherever you have a blank, and then ones wherever you have a value. So having a bunch of zeros and ones is not really what we're looking for. So how do we make that something useful? We're going to take the result of this operation here, all the zeros and ones, and multiply it by something that'll make it useful. So put in the multiplication symbol, the asterisk, and then type in row, R-O-W, open parentheses, and then again column H, and then close parentheses. The row function is something that simply takes a cell reference and tells you what row it's located in. So if you were to type equals row and then put cell B6 in parentheses, the result of that formula would be 6. Now here, we haven't put in a cell reference, we've put in an entire column. So once again, we're doing some array math. By putting this entire column into the row function, I have essentially created an array that lists out the row number for every cell in column H. But then I'm multiplying that by a bunch of ones and zeros. Wherever you take a row number and multiply it by a 0, your result is going to be a 0. Anywhere that you multiply the row number by a 1, the result is going to be the row number. So by taking this first array and multiplying it by this row number array, we basically end up with a bunch of zeros wherever we have blank cells, and row numbers wherever we have cells that contain a value. So again, if you'd like to see this visually, here's that first array we created where we checked if each cell in column H is not blank. So the resulting array is basically a bunch of zeros and then ones where you have cell values. Then we took the row function to create an array that contains all the row numbers in column H. Then we multiplied the two arrays to get this result right here. Zeros corresponding with blanks in column H, and then row numbers corresponding with values in column H. And by looking at this, we can see the result we want to retrieve is 36. We want to find the last cell containing a value in column H is located in row 36. Another way to phrase that is we have this new array here with a bunch of zeros and row numbers, and we want to find the largest number contained within this array. Well, thankfully, there's a function for that in Excel called max. The max function takes any set of values and finds the maximum or largest value in that data set. So in this case, let's wrap this entire function in a max function. So I'm going to click right here between the equal sign and my first open parentheses and type in max. Then open parentheses, and then on the other side of this row function, I will put close parentheses. Enter. And you can see we get the value we're looking for, 36. Now, if you are using Excel 365, you're done, the formula works, and that's great. If you're in a previous version of Excel, it won't do this sort of array math on its own. You need to use an array function. That's the special sort of formulas you might have worked with in the past, where instead of pressing enter, you press Control-Shift-Enter, but we can actually do it in an even simpler way. There is a function in Excel that'll allow you to do certain array calculations without having to do a special array formula or anything like that. And it's the sum product function. So what you're going to do is wrap this entire formula in a sum product function. So I'm going to click between the equal sign and the max formula and type sum product. Then I'm going to open parentheses, and on the other side of my formula, I'm going to put another close parentheses. Then click enter. I won't go into a lot of detail into why the sum product formula works here. We could do a whole separate video on that. I'll just say that the sum product function is one that allows you to complete certain mathematical operations involving arrays. Now, if we want to find what value is actually located in the 36th row, you can use an index function. And if you need a reminder on what the index function does or how it works, I'd recommend you check out my video on the index match function, and I'll put a link to that. You can click on the card in the upper right corner. Here, to keep it simple, under value, type in equals index, then select column H, that's the array where we're looking for a value, comma, which value are we looking for? We're looking for the 36th value. So I'll select cell D5, then close parentheses and hit enter. You can see it correctly tells us that the final value in column H contains the phrase last value. Now, what if we wanted to get the address of that cell? This can be done very simply with the cell function. So type in equals cell. And what the cell function does is it returns the requested attribute of a cell. So for example, it can tell you the color of a cell if it's highlighted. It can tell you the width of a cell. In this case, we want to know the address of a cell. So you can put the word address in quotes, or if this helpful little menu pops up, you can click on address, and that'll do it for you, the word address in quotes, and then comma, and then we just need to tell it which cell we're interested in. And here we can again use the index function. So I'm going to type in the exact same function we just typed a second ago, index, We're looking at column H for our array, and then which cell or value do we want? We want the 36th cell. Then close parentheses for the index function and close parentheses for the cell function, and then press enter. And there you go, we get cell H36. And now to replicate this for a row, we don't really need to do anything differently. The only change will be that instead of column H, we'll be selecting row 11. So I'm not going to go through every step of that again. All I'm going to do is copy the formulas we just built. I'll copy them and paste them just below in row 6. And then I'll go back through and modify the formulas as needed. So in our first formula, where we retrieve the column or row number, I'm going to replace our reference to column H with a reference to row 11. So all I did there is I went into the formula, I deleted our first instance of H:H, and then clicked on row 11. And then I'll repeat that over here where we have column H in our row function. Now we're also going to need to change our row function because everything in this row here is located in row 11. We're no longer interested in row numbers. Now what we're trying to find is a column number. We want to know which column contains the last value. So rather than the row function, let's delete that and use the column function, which does basically the same thing as the row function. You give it a cell reference and it tells you which column it's located in. And you can see we correctly find that the last cell containing a value is contained in column CL, which is the 90th column. For the other two formulas, we'll just make similar quick tweaks. So replace H:H with row 11, and then the same thing for the address function. And we're done. That's how you find the last cell in a row or column, returning the row or column number, the value located in that cell, and the cell address. Now, let's look at how to find the first value in a row or column. At first glance, you might be tempted to take this max function and say, oh, easy, let me just replace that with a min function. That's not going to work because remember, the array we created by multiplying these two functions contains a bunch of zeros. So if you run a min function, in this example, we would want to find the value 21. But if you're looking for the minimum value, you're going to find 0, because 0, of course, will be lower than any of these row values. Instead, we'll use the match function. Again, if you need a reminder on what that does, click the card in the upper right corner to see my video on the index match function. But briefly, the match function essentially looks for a value within an array or range of cells and tells you which row or column contains that value. If the same value is repeated multiple times, for example, if I'm looking for the value 1 and there are a bunch of 1s in the row or column, the match function will give me the row or column that contains the first instance of the value 1. That can be tweaked in the function, so it's not always the case, but the way we're using it today, we're going to make sure that's how the match function works. Before we type out the formula, let's go back to our visual example and figure out what kind of a formula we need. So I just mentioned that the match function can search for a value, and if a column or a row contains many instances of that value, it will simply tell you where the first value is located. Well, that works perfectly for this array right here, where we have a bunch of zeros for blanks and a bunch of 1s for values. That means if we use the match function to search for the value 1, it will tell us where the first 1 is located, and that's exactly what we want. Now, one thing we'll need to remember is the result of our array function, HH is not equal to blank. I originally said it gives you a bunch of trues and falses. And then I mentioned that Excel treats true and false like a 1 or a 0. One nuance to that is Excel will only treat true and false like a 1 or 0 when you try to involve the true or false in some sort of mathematical operation. So in our example, we multiplied row numbers by the trues and falses. So by applying any kind of a math, true, true, and false, Excel says, well, I can't multiply something by true or false, so instead I'll use 1 or 0. That slight nuance means that when we're using our match function, we won't be searching for the number 1, but we'll be searching for true. So without further ado, let's go ahead and type our match function. Equals match. What are we looking for? We're looking for true, so type true. And where are we looking for it? We're looking for it in our array that contains false wherever there's a blank and true wherever we have a value. Remember, how did we create that array? Column H is not equal to a blank. Then comma, and we're looking for an exact match. So put in a 0 and then close parentheses. And we find that the first value is located in row 21. Now, again, if you are using Excel 365, you're good to go. If you're in a previous version of Excel, simply wrap this function in a sum product formula, just like we did up above. So that means take this entire match function and put it inside sum product. So sum product, open parentheses before the match, and then close parentheses after the match. And then I'm going to go ahead and copy our value and address formulas from above and paste them right next to the formula we just wrote out, and they should work just fine. And just like we did in the last cell example, we just found the first cell in a column. Now we want to find the first cell in a row. So just go ahead and copy the formula we just typed out, paste it in the cell below, in cell D9, and just replace our reference to column H with a reference to row 11. And you'll see, again, we correctly find that the first cell containing a value is in column Q, which, if you need a reminder, is the 17th letter in the alphabet. And then just to finish out our example, I'll copy down our value and address formulas and then just make the necessary tweaks. So instead of column H, we're looking for row 11, and the same change in our address function. And there you go. You've now found the last or first cell in a column or row, looking at the row or column number, the value, and the cell address. In today's video, we'll look at how to join a first and last name, or really join any two text strings. So we'll see how to go from this to this. As always, if you'd like to follow along with this example, click the link in the description to download a copy of this example file. So we have two columns, one with first name and one with last name. Let's label a third column for full name, where we'll combine the first and last name. In the Excel world, we refer to this as concatenating. So we're going to concatenate the first name with the last name. There are actually two ways to do this. I'll show you both of them and then tell you which way I personally like better. In cell C2, next to the first person listed, I'm going to type equals and then start to spell out concatenate. I can see Excel has already found the function I'm looking for. I'm going to hit the down arrow to move to concatenate and then hit tab to grab that function. What the concatenate function does is if you list out a bunch of text strings, each separated by a comma, the concatenate function will combine them for you. In this case, we want to combine the first name, so I'm going to select that, cell A2, then hit comma, and then select the last name, and then close parentheses. You'll see once you press enter, the concatenate function has combined the two names. But there's a problem. We want to have a space between the first and last name. So the concatenate function joins text strings. In this case, we've joined the first name and the last name. If we want to include a space between the first and last name, the space itself is a text string. So we'll want to add a third string to this concatenate function between A2 and B2. I'm going to go directly into the formula, and when you enter a text string directly into a formula, you need to put that text in between quotes. So in this case, I'll enter quote, space, quote. So I've entered the space text string and I've put it in between quotes, and then I'll hit comma. So now we're joining 3 text strings. First name, space, last name. When I press enter, you'll see we got the desired result. And now, if you want to carry this formula all the way through to the bottom of your data, to the bottom of all your names, you can simply double click on the square in the bottom right corner. And you can see we now have a joined first and last name for everyone on this list. So I mentioned there were 2 ways to do this. Let's look at the other way. Excel also allows you to join or concatenate text strings using the ampersand symbol. You simply have to list out your text strings with an ampersand in between each string, and they'll all be joined. So in this case, we want to grab the first name, so I'm going to do equals the first name, so I'm directly referencing that text string, ampersand, and remember we want to have a space, so I'll put a space in between quotes, ampersand, the last name. And now, just like the concatenate function, we will join the first name with a space with the last name, and I'll press the enter key. And then again, we can double click the square in the bottom right corner to carry this function all the way down. So what's the difference between the concatenate function and using the ampersand key? There really is no important difference between them. The concatenate function does have a limit where it can only combine up to 255 text strings, whereas the ampersand key does not have that limit, but I can't really imagine a scenario where you would have to join 255 text strings. So it comes down to a matter of personal preference. I like to use the ampersand simply because it requires fewer keystrokes, but if you like the concatenate function, and some people prefer the way it looks, you can go ahead and use that and it'll work just fine. Let's look at the best way to delete every other row on an Excel spreadsheet. As always, hit the link in the description to download the example file so you can follow along. A lot of tutorials will tell you to do something like write a 1, a 0, 1, 0, alternating all the way down your spreadsheet, put a filter on this, filter to zeros, and then delete those rows. That method works, but we can do it in an even faster way and take out at least one of those steps. In this example, let's assume we've imported some data, and the data's pretty good, but every other row in the data is junk. You can see all of these dotted lines. We don't need those, and we want to get rid of them. Our data is set up so that we have one good row, then a bad row, then a good row, then a bad row, etc. So let's take the first example of that iteration, these first 2 rows. We want to keep the first row, we want to get rid of the second one. So in that second row, you can type the word delete. It doesn't have to say delete, it could be just an X or really any other character, but for the sake of simplicity, let's write out the word delete. Then we want to copy that all the way down through to the bottom of the data set. The quickest way to do that is to select the first 2 cells in the column where we just wrote delete, and then double click on this little square in the bottom right corner. That'll automatically repeat the 2 cells that you selected and repeat that pattern all the way down to the bottom of the data. Now, select the column, and we want to select every cell that says delete. You can do that by clicking on the Home tab on the ribbon, then under Editing, go to Find and Select, and then go to Special. Here, select Constants, and then press OK. Because all of the other cells are blank, the only cells that contain constants will be the cells that have the word delete in them. Now, all you have to do is delete all of the selected rows. You can do that by, again, going to the Home tab, then under Cells, select Delete, and finally delete sheet rows. And just like that, you've deleted every other row on this spreadsheet and you have nice, clean data. One important point to remember is that the column where you write delete must start as a totally blank column. So if you have to insert a column, that's okay. But usually if you scroll all the way to the right of your data, you can just use the first blank column after the end of your data set. And by the way, you can use this method not just for deleting every other row, but for any increment. For example, let's say you wanted to delete every third row. If you go to our Every 3 Rows tab, you can repeat that same example. In this example, we get 2 good rows of data, then a bad row, 2 good rows, then a bad row, and on. So once again, we'll write delete next to the row we want to get rid of. And this time, instead of selecting just 2 cells, we'll select 3 cells. And then again, double click on the little square. The rest of the steps are exactly the same. Select the column, home, find and select, go to special, constants, then home again, cells, delete, delete sheet rows. And once again, we have a good, clean data set. Just for fun, let's do that one more time using a couple of keyboard shortcuts to make the whole process even faster. Once again, we'll type delete next to the row of junk data that we want to get rid of, select those first 2 cells, double click on the little square, and now while we have most of this column selected, I'll use the keyboard shortcut to select constants. Alt-H-F-D-S-O, enter. And now with all of the deletes selected, I'll use the keyboard shortcut to delete rows. Alt-H-D-R. And now we've got clean data. I'll do that again quickly for the Every 3 Rows tab. And we have good, clean data. Today, we'll look at how to split first and last names, or really split any text string that's separated by a space or any other character. So we'll see how to go from this to this. First, select the column containing the data you'd like to split. Then on the ribbon, click over to the Data tab and then Text to Columns. You can also access this feature using the shortcut Alt-A-E. The Text to Columns tool in Excel allows you to take a column and split it into multiple columns using a couple of different methods. There's the fixed width method, which, as the name suggests, allows you to set a fixed point where you want to split the columns. In this case, we want to use the delimited method. So check off delimited and then click next. What that does is allow you to pick a character or a delimiter, and Excel will break the column at that point. By default, you'll likely have tab selected. So uncheck tab and check space. The reason we're checking space is because our first and last names are separated by a space. So by checking off space, you're telling Excel that's where you want to split the column. And down here, you get a preview where it looks like it's doing exactly what we want. This line indicates that we will be splitting the column in between the first and last names. At this point, you can click Next for more advanced settings, but actually we don't need to change anything else. So you can go ahead and click Finish to see the results. You can see that our names have been split between first and last into 2 separate columns. The last thing you need to do is just fix the header here. If you recall, cell A1 said full name, so now we have full in one column and name in another. Let's go ahead and change those to first and last. And then just to keep our formatting consistent, I'll go ahead and bold our last column. I'll double click in between columns A and B to fit the width to the names and do the same for the last name column. And now we have a good, clean list where our names have been broken out between first and last. Today, we're going through the index match function in Excel. Index and match are actually 2 different functions that are linked together because of how often people use them in conjunction with one another. When combined, index match creates a great way to easily and dynamically look things up. You'll often see it referred to as an alternative to the VLOOKUP function. For example, if you have a list of products and associated prices, index match allows you to look up those prices. In this example, we have a drop-down where the user can select a product, and when they select a product, we have an index match function that automatically looks up the price for that product. One of the reasons I say index match is flexible is because it works for data that's stored vertically, but it also works for data that's stored horizontally. In the first example, you can see our index match function is referring to that vertical tab, but we've replicated the same functionality using the horizontal data. Just like we saw above, right here we can select a product and it will look up the price, but you can see it's looking up that price from the product list horizontal tab. We can also do more complicated things if we use an index match match. For example, rather than simply looking up the product, let's say that we have more detailed information. On the product list complex tab, we have our same list of products, but imagine a scenario where we change the price for each product every month. So in this example, we have 12 prices for each product, showing us, let's say, the price each month last year for all 6 of our products. Using an index match match, we can do a lookup across both product and month. So in this example, the user can select a particular product and then pick a specific month, and we can see the price associated with that product in a particular month. So in this example, we're saying the price of a T800 was $3,717 in October. So how do you write your own index match or index match match formula? We'll go through an example where we recreate the formulas we just looked at. If you'd like to follow along, as always, hit the link in the description to download a copy of this example file. When you open your file, you'll see something that looks just like this, except where I currently have formulas, yours will be blank. And that's because we'll be writing these formulas together. To understand index match, you first need to understand the index function on its own and the match function on its own. So let's start with the index function. What does the index function actually do? You can think of the index formula as taking a set of data that can be a row of data, a column of data, a combination of the two, but taking a set of data and picking out one piece of information from that data and handing it over to you. In this example, the set of data is all the prices, and the piece of information we're looking for is a specific price, namely the price for the product that the user has selected. In this example, let's say the user has selected the T800. Let's use the index function to grab the price for a T800. So in the highlighted cell next to price, type equals index, open parentheses. The first thing that the index function requires is an array, meaning the set of data that contains the information you're looking for. In this case, we're looking for a price, so the set of data will be all of the prices. Go over to the product list vertical tab and select all of the prices. So that'll be cells D6 through D11. Then press comma. The next thing you need to give the index function is which item in this set of data are you looking for. In this case, we want the price for the T800. Looking over here, we can see that the T800 is the 5th item in the list. So we'll tell the index function we are looking at the set of data containing all the prices, and we want the 5th price from that list. So hit 5 and then close parentheses. Then press enter to see the result. And we see $4,000, which is the price of a T800. You can use the exact same function even if your data is stored horizontally rather than vertically. Let's see that example. So if you go to our next highlighted price cell, so cell D15, and once again type equals index. In this case, let's say we're looking for the price of a T1000. What is the set of data we're looking for? Once again, it is all the prices, but just for the sake of an example, rather than using the prices on the vertical tab, let's go over to the horizontal tab. On the horizontal tab, we will select all of the prices, then comma, and once again, we need to tell the index function which item from this set of data are we looking for. In this case, we're looking for the price of the T1000, and we can see that is 1, 2, 3, 4, the fourth item on the list. Press 4, close parentheses. If this formula works correctly, we should see $6,000 as our result. Press enter, and we see our $6,000. We'll skip the index match formula for now. We'll come back to that example once we really have a handle on index and match. So great, these formulas are working. However, if we go back to this first example up here, in fact, let's hide the horizontal example and the index match examples for now. If we go back to our vertical example, right now, all this formula can do is pull the price of a T800. If we change the product to anything else, a toaster, for example, you can see the price doesn't change. And that's because the index function knows that we're looking at all the prices, but the part of the formula that tells it which price we want is currently hard-coded. We're telling it we want the fifth price in the list. So we need some sort of a formula that will see we're looking for a toaster and find out, is toaster the second item on the list, the third, fourth, or fifth, etc. That's where the match function comes into play. Let's X out of this formula. I'm going to hit escape. And as an example, let's type out a match function over here in cell E7 right next to our toaster. So what does the match formula do? It does exactly what we just described. You tell the match formula, I'm looking for a toaster or whatever you're looking for. And then you tell the match formula, where are you looking for a toaster? And the match formula will tell you within that set of data, where does toaster fall? So type equals match. First thing you need to tell the match function is, what are you looking for? In this case, we're looking for toaster. Then you need to tell the match function where you're looking for it. That'll be back on the product list vertical tab. We have a list of products here. So select that list. And again, what we're telling it to do is we have a list of products. We're looking for toaster. And I need you to find toaster within this list for me. So if this function works, it should come back and tell us that toaster is the second item on the list. So we've told the match function what we're looking for. We told it where we're looking for it. The last thing we need to tell it is what type of a match are we looking for. This really only comes into play when you are looking at a list of numbers. In this case, you might say, hey, we are looking at a list of numbers. We're looking at prices. But remember, prices are ultimately what we're trying to get to. But in terms of what we are specifically searching for using the match function, right now we are searching for a particular product. We are searching for text. 9 times out of 10, when you're searching for text, you'll want to use an exact match. Meaning we're looking for a toaster, match function, all I want you to find is a toaster. I don't want you to find anything else besides a toaster. Where you might use the other match types is when you're looking for numbers. In that case, you have a couple of other options besides exact match. If you input match type 1, you're telling the match function to find the largest value, which is less than or equal to the one you're looking for. If you tell it -1, that says you're looking for the smallest value that is greater than or equal to the one you're looking for. But you don't need to worry about that here. Like I said before, we only want to find an exact match, so we're going to put 0. close parentheses, and press enter. As we hoped, Excel is telling us that toaster is the second item on the list. So now it's time to combine our index function and our match function. If we go back into the index function, you'll remember we told Excel to look at the set of prices, and then we told it which price do we want from that list. Previously, we said we want the fifth item, but what we're going to do now is get rid of that 5. Instead of saying that we always want the second item or the fifth item, instead we'll use a match function to find where on the list the selected product lies. That will calculate which item we want the index formula to grab for us. So in this example, we'll have a match function that looks up toaster, finds that toaster is the second item on the list, and then we'll tell the index function, hey, you've got the list of prices, grab me the second price from that list. So where we previously had a 5, instead let's type a match function. It'll be exactly like the one we just typed out in cell E7. So what's our lookup value? We're looking for toaster, comma, where are we looking for toaster? That's back on the product list vertical tab. Select the list of products, comma, again, we want an exact match, 0, close parentheses, and then hit enter. And you'll see we are pulling in the price of a toaster. And you can go ahead and delete the function we wrote out previously in cell E7. That was just an example. So why does this work? As a recap, we gave the index function a list of prices. And then we have to tell it which price do we want from that list. So we have a match function that takes the product in question and finds where it is on the list. If I press F9, we can see that the match function here calculates to 2. So the index function has a list of prices, and we are telling it we want the second item on that list. I'm going to hit escape to leave this formula. You can try picking other products from this list, and you'll see that the formula updates correctly to give us the price for that product. We can see that the same logic works with the horizontal data set. Let's go back to the horizontal example, and I'll move a little bit quicker this time. So in the horizontal example, we already put in our index function, so we're already telling index that we're looking for a particular price on the horizontal tab. We're looking for a particular price right here. So all we need to do is put in a match function so it's not always looking for the 4th price on the list, but will be dynamic based on whatever the user selected in the drop-down menu. So let's type match. What are we looking for? We're looking for the product the user has selected, comma, where are we looking for it? That'll be on the horizontal tab. Once again, we select the list of products. The only difference from the previous example is that the list is stored horizontally rather than vertically. What type of a match do we want? We want an exact match. That'll be a 0, then close parentheses. And just like the example above, we see that we can pick different products and easily get the price from that list. Okay, so you've got a couple of great index match formulas. You're starting to get a handle on it. Let's go to a slightly more advanced example, the index match match. This is the example where we're not only trying to pull the price of a product, but the price fluctuates month to month. We want to see the price for a particular month for a particular product. As we did in the previous examples, let's start with just an index function that works for one example, and then put in our match formulas. We'll start with the example of the T1000. We want to find the price of a T1000 in May. So let's start with the index function. Equals index. Where is the set of data? That'll be on the complex tab. We're looking for a particular price, and we know it's going to fall in this range. I'm selecting all the prices from D7 to O12. In the previous examples, we gave the index function either a row or a column. If you just give it a row or a column, The next thing you need to tell the index function is which item do you want from that list. For example, do you want the second item, the third item, the fourth item, etc. However, when you give the index function an array or a set of data containing both rows and columns, you need to give the index function not just what item do you want from the list, because if you said, I want the second or third item, it wouldn't know what to do with that. It wouldn't know if you're talking about rows or columns. So you need to tell it which row are you looking for and which column are you looking for. In this example, we're looking for the price of a T1000 in May. So let's hit comma. What row is that going to be? 1, 2, 3, 4. It'll be the fourth row. Then we have to tell it which column we're looking for. So put in another comma, and then which column do we want? We're looking for the price in May. So that'll be 1, 2, 3, 4, 5, the fifth column. Press 5, close parentheses, and then hit enter. If this works, we should see a price of $5,288. And you can see we got the price we're looking for. Now, we just need to make this dynamic using the match function. First, that 4 tells us where on the list of products the T1000 falls. So we've done this a couple of times already. How do we make that dynamic? Let's delete that 4 and in its place type out a match function. So we'll type match, open parentheses. What are we looking up? We're looking up the product. Comma, where are we looking for the product? It'll be back on that complex tab, and we'll select all of the products listed there. Comma, as always, we're looking for an exact match. 0, close parentheses. And I just hit enter so we can see how the formula is working so far. So right now, if I pick a different product, we can see that the price is updating. The only issue is that it's always going to give me the price for that product in the month of May, because our 5 is still hard-coded. So we've made the row selection dynamic. Let's similarly make the column selection dynamic. So get rid of that 5 and then type another match function. Match, what are we looking for? In this example, we're looking for the month. So select the month. Then hit comma. Where are we looking for the month? We are looking for the month in the row that contains all of your months. Then press comma, and once again, we're looking for an exact match. 0, and then close parentheses. Then press enter. Great. Now we have a fully dynamic index match formula. We can pick a different product, and we can pick a different month. And you can see that when we do that, our index match gives us the price for that particular product in that particular month. All right, that'll do.